Hello, everybody. Welcome to the next conversation we're going to have about chemical bonds. So we're going to cover sections 18.1 and 18.2. Let's get started. First thing you need to know about chemical bonding is the reason that they bond is that elements and compounds have stability when they bond. As each atom forms compounds, each atom is more stable than when it was by itself. Compounds is another way of saying elements that are combined chemically under the right conditions. And so, for instance, copper by itself is just Cu, and when new or brightly polished, it has a bright and metallic sheen. The picture here shows the Statue of Liberty after it had been recently cleaned many years ago. But as time has progressed, the copper gives way to this green color, and that is actually the patina, the corrosion that happens on there, and that's when oxygen and sulfur in the air combine with the copper. We get what's called copper sulfate. And copper sulfate is why the Statue of Liberty is green. It's actually made of copper, but it rusts and makes a different compound when exposed to air and oxygen. And the new compound has different chemical properties than the original element. So one thing to remember about a compound is that although it has some of the elements of the original elements that joined into it, it has all new properties. Think, for instance, of steel. Steel has brand new properties, even though it's got iron and some nickel and some chromate and some other things like that in it. But it has some different characteristics than the individual elements. Formulas. What is a formula? A formula shows what elements a compound contains and then also the exact number of the atoms in each element. We use formulas when we're writing down particular compounds and all that kind of stuff. For example, sand. I don't know if you knew that, but sand is actually silicon dioxide. And then we write, that's the name, silicon dioxide, and then we write the formula as SiO2. And that is the formula for sand. So each element will have their own atomic symbol, which is the letters, and then it also have the number of those atoms in the subscript. So you can see from our example up here, silicone's by itself, which means it's just one atom of silicon, and then we have two atoms of oxygen, so that's why it's dioxide. Okay? Here are some familiar compounds that you may have seen around the house. Did you know that cane sugar is actually made of sucrose, which is C12H22O11? Vinegar is also known as acetic acid, CH3COOH. And these are all the chemical formulas for different things. Your stomach is consisted of hydrochloric acid, which is HCl, so one atom of hydrogen and one atom of chlorine. Chemical bond formation. Why do chemicals bond? Why do things happen? You remember we talked about that a little bit ago last week when we were talking about how the periodic table is laid out and with the different electrons that are available for bonding. Well, atoms form compounds because they want to fill their outermost shell with electrons. And you remember that the most the complete shell is the noble gases, and those have 8 in the outer shell, and that is when they are the most happy. And we use what we call electron dot diagrams to show the electrons of the outermost shell. On your periodic table of elements, you'll notice if you look at the column number 1, family 1, the alkalis, they all have 1 electron. In this period right here, this table, it shows that they all have 1 dot, and then so on as we move across the table. And the nice thing about electron dot diagrams is you can actually show how the electrons meet up when we're making compounds according to their electrons. And what is a chemical bond? I probably should have talked about that before I jumped into how it's all formed and what electrons do. But a chemical bond is the force that holds atoms together in a compound, and this is due to the electrons that they share. What are some different types of bonds? Well, the first type of bond we're going to talk about is an ion, an ionic bond. You may have run into the ion before. We talked about it, that it's an atom or an element that has an uneven electrical charge. It can be positive or negative, and that is due to whether or not it has more electrons than protons. An ionic bond is formed when atoms transfer electrons. The electrons are actually taking away from one element to another element. And the force of this attraction is caused by the opposite charges of the atoms. For instance, an ionic bond is NaCl. Okay? One atom will be negative and the other atom will be positive. We have what's called the cation and the anion. The cation is the positive one. Some people like to think of it as if you are a cat owner, you have a positive outlook on life. And then that's how they remember it. It's positive. Cations are positive, and anions are negative. Okay. And the only one that I've heard about that one is an onion. And onion is negative, makes your eyes cry, so you have a negative feeling. Anyways, zero net charge. So what happens after we have these two ions joining together? And that's shown by these brackets here with the plus and minus. When they join together, you'll see that chlorine has pulled the electron away from sodium, and so now it has one extra electron, which means it has a negative charge, and because sodium has lost an electron, it now has a positive charge. And when these two elements join together to make a compound, a single grain of salt, it actually has a net zero charge because the negative and the positive, they balance each other out. And so the salt is a a neutral compound. It doesn't have a charge. You can't pick it up with static electricity or something like that. Ionic bonds are usually formed between metals and nonmetals, and they usually form crystalline solids. Think about your salt. It is a crystalline solid. Another type of bond that we're going to talk about is covalent bonds. Covalent bonds are the attraction that forms between atoms when they share electrons. And unlike ionic bonds, which take the electron away, covalent bonds, they just kind of like mutually, they both hang on to the electron. And the molecule is then created when two or more atoms form covalent bonds. A lot of the molecules in our body are all held together by covalent bonds. They share electrons. And again, ionic bonds lose and gain electrons. I've repeated it a few times, so it's probably important. It will probably be on a quiz, so make sure you get that down for your notes. A covalent bond consists of pairs of shared electrons, and you can have multiple covalent bonds. For instance, oxygen. Oxygen usually doesn't exist out in the universe by itself. It's usually joined with another molecule of oxygen called O2. So oxygen as a gas is O2. And so what happens is it shares a covalent bond between not just one set of electrons, but two sets of electrons. And so that's notated here when we draw this solid line between two different elements when we do in Lewis structures. Okay, so covalent bond, they share it. It's a very, very strong bond. Covalent bonds tend to form between non-metallic elements, typically your gases and your nonmetals. Then we have polar and nonpolar bonds. A nonpolar bond is a covalent bond, but where there's an electron charge that's shared equally across the bond. So think of a pole, like the Earth is polar. We have a North Pole and a South Pole. So there's a positive charge and a negative charge on either end, like a large magnet. But a nonpolar, it doesn't actually have any charge that's uneven around the surface of the molecule. A polar bond is a covalent bond where the electron charge is unequally shared. This causes a positive end and a negative end. So think of like your magnet, okay? Positive and a negative end. Nonpolar molecules, again, do not have a difference of charge on each end. Nonpolar means they don't have a charge different anywhere on their structure. Okay? Polar molecules have an unequal sharing of electrons, resulting with a different charge on either end. And one of the ways to show that is over here with water and H2O. It's polar because here we have a hydrogen atom, and then we have these two little purple ones, which is our H's. Hydrogen is the purple ones, oxygen is the large blue one. So we have two hydrogen atoms attached to the oxygen to make water. Well, there's a couple extra electrons that oxygen already has, and they're on the other end of the molecule. So water is actually a polar molecule because we have a negative pole with the negative electrons on one side and then the positively charged hydrogen atoms on the other side. Ammonia, NH3, it also is polar because we have an area that doesn't have another molecule or atom bonded to it, so there's a pair of lone electrons. And so wherever there is a pair of lone electrons on a molecule, there typically will be a polar charge there, a negative side, and then obviously they'll have a positive side on the other side. And also here on the corner we have methane, which is CH4, and it's nonpolar because you can see the hydrogen atoms are split equally around the carbon molecule, and so there is no charge in that. That's why it's called nonpolar. And we often return to oxidation. I'll bring it up here now because oxidation refers to how many electrons are gained or lost when there is a reaction, when there's bonding and things of that nature. and that will come up later on.